Reverse osmosis basics. Overview. Osmosis. Reverse osmosis definition. Row fundamentals. Reverse osmosis membrane. Parameters affecting row systems. Air gap faucets. Row maintenance. Quick connect fittings. Troubleshooting. Reverse osmosis basics. Osmosis is a natural phenomenon that provides water to all animal and vegetable cells to support life. Water moves from a high concentration of water, less sugar/salt dissolved in it, to a low concentration of water, more salt/sugar dissolved in it, across a semi-permeable membrane. This means that water can cross a selectively permeable membrane from a dilute solution, less dissolved in it, to a concentrated solution, more dissolved in it. Reverse osmosis basics. Osmosis, what is it? Reference, // Privet Dr. A semi-permeable membrane is a membrane which will allow only certain molecules or ions to pass through. Osmosis is very important in biology as it provides the primary means by which water is transported in and out of cells. Net movement of water molecules. Reverse osmosis basics. Reverse osmosis, what is it? RO is a form of filtration using osmosis in reverse. Water passes from a more concentrated solution to a less concentrated solution. To accomplish this, a force or pressure must be applied. RO requires 1 pound per square inch of pressure for every 100 parts per million of TEEDs. RO is used to remove dissolved solids from water, but it can also improve taste, odor and color of water. RO membranes have the capability to remove particles as small as ions, i.e. magnesium ions or sodium ions. RO membrane will reject most compounds based largely on size. Dissolved ions, such as salts, carry an electric charge and will also be rejected by membrane. Reverse osmosis basics. Osmosis, how does it work? Feed water flows into RO unit with a force of line pressure. Water is forced through membrane by cross-flow filtration. Cross-flow filtration is most commonly used in RO as it allows membrane to continually clean itself. Membrane then either rejects or repels contaminants. Two exit streams generated, waste and product stream. Waste stream consists of a concentrate, reject, stream which carries contaminants, compounds too large to pass through membrane. Permeate stream consists of product water which has been forced through the membrane and is virtually free of TEEDs. Reverse osmosis basics. Reverse osmosis schematic. Reverse osmosis basics. RO membrane. Reverse osmosis basics. Reverse osmosis fundamentals. Feed water, main flow of impure water to be treated. Product water, portion of feed water which passes through membrane as permeate. Reject water, portion of feed water which did not pass through membrane, carries impurities to drain. Module, combination of spiral round membrane element and pressure vessel. Reverse osmosis basics. Spiral wound membrane. RO membrane is a method of fine filtration but much smaller. Membrane consists of tiny pores which are approximately 0.0005 microns in size. Therefore reverse osmosis membranes are capable of rejecting contaminants as small as 0.0001 to 0.00001 microns. Thin film composite membrane, TFC. Reverse osmosis basics. RO membrane. Membrane is the workhorse of an reverse osmosis system. When choosing an RO system you must do so wisely, taking into account water quality is very important. Three main types of membranes. CTA membrane, cellulose acetate/triacetate blend. Provides lowest cost per gallon of water. Resists chlorine but has a lower flow rate limit in applications of high water consumption. TFC membrane, thin film/thin layer composite. Can handle high flow, has a high rejection rate and can handle high water consumption. cannot handle chlorine concentrations, water must be carbon pre-filtered. Reverse osmosis basics. Membrane comparison. Reverse osmosis basics. TFC membrane. TFC membranes are intolerant to chlorine, will cause deterioration of membrane. Must choose a carbon pre-filter for TFC membranes. TFC membranes have a much higher rejection rate of many chemicals than CTA membranes. Carbon pre-filters are vital in the life of this membrane and must be changed regularly. Reverse osmosis basics. Parameters that affect RO. Water temperature. RO system ratings are based on 770 F/250 C water temperature. i.e., RO system rated at 20 GPD, gallons per day, at 340 F/10 C will only produce 6 GPD. Feed water pressure. A lack in water pressure, less than 40 psi, will reduce product water. This can be helped with the aid of a booster pump. Contaminants in feed water. Large particles, iron concentration or high levels of hardness in feed water can cause clogging of the membrane. Clogging of the membrane can decrease its life. Microorganisms. RO membranes can filter out bacteria, depending on the bacteria size. However, this may cause fouling of the membrane as bacteria can begin to grow through pores of membrane, causing bacteria creep. RO systems should not be installed on non-potable water. Reverse osmosis basics. RO production rate versus feed water conditions. Reverse osmosis basics. RO systems can remove the following contaminants. Dissolved solids equals TEEDs, salts and minerals, up to 2000 parts per million. Most heavy metals, lead, mercury, silver. Most radioactive elements. RO systems may not be capable of removing nitrates to recommended levels. Reverse osmosis basics. Typical rejection ranges of contaminants. Reverse osmosis basics. RO-treated water. RO systems will remove up to 97%, depending on parameters, of salts in water, bringing it closer to a level of pure water. The purer the water, the more aggressive it will be with materials it comes in contact with. Therefore, RO can be slightly corrosive. It's recommended never to use copper piping on RO water. Reverse osmosis basics. Typical consumer RO system. Hosed filter. RO membrane. Air gap faucet. Pre-filter. Tank. 2. Drain. Reverse osmosis basics. Under-the-counter RO system. Reverse osmosis basics. Air gap faucets. Air gap faucet is a plumbing device designed to provide a siphon break for an under-sink reverse osmosis unit. It is a valve used to isolate one part of a water system from the drain. Air gaps are designed to prevent backflow by incorporating a backflow prevention method called an air gap. Purpose of an air gap faucet is to assure that no water from a stopped-up sink can possibly be forced backward into your reverse osmosis system unit via its drain connection. Some plumbing codes do enforce the use of an air gap faucet. When to replace pre-filters. Reverse osmosis basics. RO system maintenance. When to replace pre-filters. When to replace post-filters. Every 6 months for normal installations. After a boil water advisory, BWA. Every 6 months, depending on water conditions. Noticeable decrease in water production indicates that the pre-filter should be changed. After microbiological contamination, such as in a boil water advisory, BWA. When to replace the membrane. Reverse osmosis basics. RO system maintenance. When to replace the membrane. Typically, every 18 months to 3 years. Test using a TEEDs, total dissolved solids, meter. Replace a membrane below 80% TEEDs reduction. This will depend on influent water quality, usage, pre- and post-filter maintenance. Maintain filters, lengthen life of membrane. Reverse osmosis basics.
Troubleshooting.
Q. I have an RO system and there is water coming out the back of the faucet. What's wrong? A. You probably have an air gap style faucet. What is most likely happening is there may be a clog or kink in the RO drain line causing water to come through the hole at the back of the faucet. Q. What if my hardness level is more than 7 GPG? A. The hardness level of your water will tend to foul the membrane of the system. Q. Is it true that RO systems waste a lot of water? A. With some RO systems it takes as much as 10 gallons of water to produce 1 gallon. This is an extreme case but most high-quality systems will have a 3-to-1 ratio. Q. Should you use copper tubing with RO systems? A. No. RO systems reduce up to 97% of TEEDs in water. The aggressiveness of the purified water towards materials it comes in contact with is a function of its purity. The better the purity, the higher its aggressiveness. Reverse osmosis basics.
Troubleshooting.
Q. My RO continues to run. What is wrong? A. Shut-off valve could be defective or A. Check the storage tank. It might not have enough air in it. The tank should have 7 pounds of air in it when empty. Too much air will cause an RO to shut off permanently. Q. I have installed my RO but am not getting much water from faucet. I do hear water running. What is wrong? A. For a residential system it takes a long time to produce RO water. Faucet needs to be in off position and then the tank will fill slowly. If a system is rated at 30 Us, then it will take 1 full day to produce that 30 Us. The water you hear running is the reject stream going to drain. Q. My RO system seems to work but when I want to get 3 gallons of water at once I can't get anything. Is this normal? A. Most RO systems come with a 3 to 4 gallon storage tank. Reverse osmosis basics.
Troubleshooting.
No permeate water. Membrane fouling. Pre-filter fouling. Inadequate pressure. Slow flow at the faucet. Air charge. Tank not filling. Installation of tank, tubing length, reverse osmosis basics. Quick connect fittings. RO systems cannot be installed using copper piping as product water is slightly aggressive. Plastic tubing is most commonly used in RO installations. Pipe connections are accomplished using quick connect fittings. Quick connect fittings do not need any additional special tools. Simply cut tube square and insert into QC fitting to accomplish a secure connection.